Hello. So I'm going to solve quadratic equations using this completing perfect squares technique. So I'm going to use this formula, x plus or minus a constant k square and equals x squared plus or minus 2kx plus k squared. If I have a positive here, I have a positive here. If I have a negative here, I have a negative here. Okay, so in blue, the quadratic term, in red, degree 1 term, and the constant in green here. Okay, so let me do an example. X squared minus 3x minus 5 equals 0. What do I do to use my formula here? What's the k? So I notice that if I multiply by 2 and divide by 2, I'm not changing. I still have minus 3x. But now I do this so I can have the 2 here to know who's my k. I want the linear term, x to the power 1, 2 times something. But 3 doesn't look like 2 times something, so I have to do this artificial trick. I have 2 here, and I divide by 2. So now it's going to be 2 times 3 halves. My k equals 3 halves. The k here is 3 halves. Okay? And then I need the k squared. So I add the k, 3 halves squared on here. But also to compensate, I write 3 halves squared, which is 9 over 4 on the right-hand side. So I added on the left and also on the right, so I keep the equation to be satisfied, right? To be true. To balance out, I have that. And now I have everything I need. I have the blue term, I have the red term, I have the green term, and they all come up to this using this formula here. Okay? This negative 5 here, it's minus 20 over 4. I have a 4 denominator, so I can match my denominator on the right-hand side. All right? I push this to the other side, so it becomes 29 over 4. And now I can take the square root. And if I take the square root on the right, it's plus or minus the square root of 29 over 4, which is plus or minus square root of 29 over square root of 4, which is 2. And then I add the 3 halves, goes to the other side. Okay? So here are my 2 solutions. I solved the quadratic equation using this technique of completing the perfect square. The whole thing for you. Another example. What if I have something like that? 2x squared minus x minus 2 equals to 0. Well, I put the 2 in evidence in these first 2 terms. So minus x is 2 times minus 1/2 of x. And this 2 here pushed to the right-hand side. Now I have to make what's inside of this parenthesis similar to my formula here. So the x has to multiply 2 times something. But the x is not multiplying 2 times something, it's multiplying 1/2. So what do? I multiply by 2 and divide by 2. Okay? Instead of having 1 minus 1/2, it's minus 2 times 1 over 4. 2 times 1 over 4 is 1/2, so I did not change anything. Okay? But now I know my k. My k is 1/4. K is 1/4, so I add k squared, and I subtract k squared to compensate. In the next step, I repeat x squared, I repeat this, I repeat this. Minus 1 over 16 times 2 goes outside of the parentheses, becomes 1 over 8. Okay? It's minus 1 over 16 becomes minus 1 over 8 because I have to multiply by 2 to remove that from the parentheses. And the 2 here, because I have 8 on the denominator, I write the 2 as 16 over 8. Now this whole thing here, I can use my formula again. And that's, I keep the 2, and that's x minus 1 over 4 squared. Minus 1 over 8 goes to the right. 16 over 8 plus 1 over 8 becomes 17 over 8. The 2 goes to the denominator, 17 over 16. And now I take the square root. I have the square root of 17 over square root of 16, which is square root of 17 over 4, plus or minus. And then I push this negative 1/4 to the right-hand side. Becomes a positive 1/4 plus or minus square root of 17 over 4. Okay? Here's the whole calculation. You can give a stop and follow the steps. Completing the square, I can solve equations of degree 2. No memorization required, or formulas required. Okay. Hope you enjoy. Bye-bye now.